for penetration tests. At least this is what it was created to be used for. Instead, it is commonly used by red teamers, but has also been cracked and leaked online, where threat actors will make use of Cobalt Strike within unauthorized penetration tests against companies nationwide. These threat actors will use it to bypass EDR and antiviruses, and then it is commonly used in penetrations against large companies where ransomware is the final payload. Cobalt Strike is a great tool to be used for these scenarios because it is built to be used within these environments. It can be used along with different kinds of C2 profiles, such as malleable C2s. And what these allow for an actor or a red team to do is to create different profiles for how the C2s are carried out, which means that you can use these to bypass AV by creating your own form of C2 communications, along with changing how the binary operates. And all of this put together will make for it to be a very difficult to detect piece of malware. But of course, sometimes we see that malware has flaws, and Cobalt Strike is not exempt from this. So we'll be looking at how this new XSS in Cobalt Strike can be achieved and why it happens. Let's get into it. So I've gone ahead and created a beacon from my Cobalt Strike instance. And what I'll do is go ahead and run this on my VM. My C2 and my research VM are both connected over a VM network. So running this, it should show up in my Cobalt Strike instance on my other VM, which we see here. So now we can get an idea of what Cobalt Strike will be able to do. It can dump hashes, explore the computer, pivot, and a bunch of other functionality. If you're familiar with Meterpreter, then you'll be familiar with some of the functionality that Cobalt Strike offers. But now that we have this view, I'm going to touch on the exploit. Well, the exploit relies on this part of the view within the Cobalt Strike client. It can work on other information from the host that's been infected, but most of the POCs you'll see online concentrate on the user because it's very easy to edit. So how the exploit works is that it will replace this user here with HTML, which will then actually be rendered by the Cobalt Strike client and will carry out XSS on the threat actor or the red team that's using it. This is quite interesting because this is a client, and usually you see XSS being used within websites because it usually will rely on HTML. But that's the funny thing about the Cobalt Strike client, and what we'll touch on later is that it does actually use HTML within the client. So let's show a quick demo of how this exploit works. So I've gone ahead and downloaded a POC for this exploit off of the GitHub listed here. This POC is making use of a script given out by researchers that will take the configuration of a beacon and get some of the information needed for this exploit. What's needed from this exploit is the RSA key for the encrypted communications to the C2. This is standard with Cobalt Strike C2 communications when you use the HTTP listener. All of the communications to the C2 will be sent encrypted through a cookie header within the HTTP request. So it will take this key and encrypt the communications along with extracting the URI of where this HTTP communication should be sent to. Above, we can see some of the data that's being sent to the C2. This information is packed and within bytes, so it's not easily readable, but the author has nicely annotated it for us. So we can see the AES key, some of the char sets, the beacon ID, which is uncommented here because it's randomized, but you can set that yourself, the beacon port, flag, Windows version, and so on. This is all very interesting if you're looking to replicate Cobalt Strike C2 communications, but what's most important here is our exploit. You can see that this exploit is simply putting in some HTML. This HTML is what's going to be displayed to the user of the Cobalt Strike client. Instead of this image source, I'm just going to change it to something that we can easily see. Now that I've changed the exploit, I can go ahead and execute this POC, and I will go ahead and execute the exploit. We can see that it's sent to our URI here. This looks correct. So let's check our client, and within our client we can see the exploit. So you can clearly see here that this really shouldn't be here. I put h1 tags in the HTML that's being sent to the client, and you can see that's why this username is bold. And in our session, we can actually see the exploit in its entirety here. So this exploit isn't perfect because a operator of the Cobalt Strike can see the exploit being sent to their C2, but really it doesn't matter because once they notice, it's going to be too late. So we can see that the client is executing HTML, but why is this? Well, let's go ahead and pick apart the Cobalt Strike client and find out why this exploit actually works. So I've gone ahead and opened the Cobalt Strike client within JD GUI. JD GUI is a Java decompiler, which I'm a huge fan of. It makes decompiling Java incredibly easy and it's quite a lightweight program. Now, looking at the client itself, we can see a lot of different classes here. It would be difficult to know where to start, but because I've already looked at this client within my own research, I know that what we're looking for is within the table section. And if I look at filter panel, we can see some of the code that will filter the sessions layout. But this isn't really what we're concentrating on because the exploit doesn't actually lie here. It lies in the class that is being used to create the table view for the client, and that would be JavaX Swing. So Swing is a library that can be used to create tables, among other things, and Cobalt Strike makes good use of it. It's used in all kinds of views within the Cobalt Strike client. The issue with this library which is used is that it does use HTML rendering, hence why we can get XSS using HTML. And you can see this here. When it creates an error, it will use an HTML body and then use default HTML styling to create a red error. And what Cobalt Strike fails to do is it fails to check or escape any XSS or HTML tags that are coming in from C2 communications, making our exploit. So I've gone ahead and looked up the documentation for Java Swing. Looking in the documentation, we can see how to use HTML and Swing components. Again, this is why HTML is used within this library, and it's just for styling purposes rather than actually for functionality. Thank you so much for watching. I hope that this was a good quick introduction to the Cobalt Strike exploit, and I'll catch